activity, and it's so important that government and commercial companies talk and work together. I've worked at 4 NASA centers in my career. 10 years ago, I was the NASA space architect, and we had a team around the country working hard on how humans can go above low Earth orbit. In fact, before the vision came out by George Bush, we weren't allowed to talk about it. And it's great to sit here and actually talk about words like settlement and about how we're going to open this frontier, and to have NASA people allowed to be part of this and looking at how we can work together to make that happen. So I'm really happy to be here on this first panel, because this is where it's really going to happen soon. We're at the dawn of a new age where we're going to prove these new markets are there, and that we're going to be able to capture everyone's imagination. In fact, very soon, anyone in this room or anyone anywhere will be able to ride into space or to do low gravity experiments for short periods of time into space. And this is a really great way to open the frontier. So the way we're going to do it today for this panel is I'm going to introduce each of them, and then I'm going to ask each of them from where they're sitting to give us 2 or 3 minutes of their background and what they're doing. And then I'll ask one question while everyone's warming up and I understand how to use this. And they'll all answer this one question, and then the rest will be from you. And so we'll get started right now. Our panel is made up of Dougal McLeese, who's the manager of Cruiser that Laurie mentioned, which stands for Commercial Reusable Suborbital Research Program, if you weren't familiar with the acronym. Dougal is right there. Raise your hand so if people know. Sorry. Sean Mahoney, who is the Chief Operating Officer of Maston Aerospace. And Kaki McKee, who's the Program Manager for Air Corps Aerospace. That's it wrong? X-Corps. Thank you. Sorry, my eyes aren't so good. The Will Pomerantz, who's the Vice President of Virgin Galactic. And Tim Pickens, who's the Chief Propulsion Engineer for Dynetics. Thanks. All right, so what we'll do is maybe we'll just go from left to right. And if you would just say a little bit about your background and what you represent.
Good morning. My name is Sean Mahoney from Maston Space Systems. For those of you who are not familiar with what Maston does, we are building a fully reusable vertical takeoff and vertical landing rocket out in the high desert of Mojave, California. The focus of the company in the immediate term is being able to provide cheap, fast, responsive suborbital space access so that your projects, your research, your technology development testing can be done in a quick and reliable fashion. Looking slightly beyond, today is what sort of things will we have in the immediate term. We are looking at focus on being able to do nanosat launch and being able to do orbital launches a little bit further down the technology roadmap. We are specifically focused on your payloads, and luckily there's a few counterparts here who can talk about being able to carry you to space. Right now, the only way you would wind up on a Maston rocket is if you wanted to have your mortal remains distributed in space. That's about the only way that we're going to fly humans at this point. So,
thank you very much. Kiki?
Hi, I'm Kaki McKee. I'm the program manager at X-Corps Aerospace. My bio's in there, so I'm not going to tell you all about me, but X-Corps means space business. We're located at the Mojave Air and Spaceport, which is near Sean. In 11 years, we have designed and built 12 different rocket engines and had over 3,500 test firings of said engines. We've built and flown 2 generations of rocket-powered vehicles, a total of 66 times, and we do like to tell you that we have 50% of all rocket-powered flights in this century. We're building a suborbital vehicle that will have multi-mission capabilities, and it's called the Lynx. It's a piloted two-person horizontal takeoff, horizontal landing vehicle. It has wings. We're funded by angel investors and sales and contract revenues. We don't have a billionaire who with deep pockets, who is the company founder. Our founders founded the company because they want to go to space and they want to take others with them. And the way our business philosophy works is we start with incremental steps. We focus on safety and reliability and responsiveness, and therefore we've gone from the first vehicle, which is a single person small vehicle, to a two-person vehicle, and next will be both low performance. The next one will be a suborbital vehicle, and we can talk about that later. Thank you.
Great. Dougal?
I'm Dougal McLeese from NASA Ames. I have been the manager for the Cruiser project. The Cruiser project has morphed some, and I'd like to explain that to you quickly so you all understand. The Office of the Chief Technologist has come up with a whole new organization that is going to really start developing new technologies. As part of that, they have the Flight Opportunities Program, and within the Flight Opportunities Program, there are two main methods for demonstrating and testing new technologies. One of them is what has been called Cruiser. We're now going to start referring to that more as the suborbital reusable launch vehicles, or suborbital RLVs. There's also the former FAST program, and I always struggle with this acronym, but I think it's the Facilitated Access to Space Technology, Space Environment for Technologies. That was what a lot of us grew up knowing as the Vomit Comet, or the Zero-G Corporation airplane that does the parabolic flights and tests technologies, experiments out in microgravity for about 20 seconds at a time. My role now is the payload manager for that program. We just completed the first week of the fast flights, and I have to say it was very exciting to see what people are testing out. We had one payload looking to grab satellites with a remote operated, telerobotic operated robotic arm. We had another group testing fuel transfer for propellant storage in space. Another group printing parts with a 3D printer called Made in Space. This is now the beginning of it. We're looking forward to a great future as we start developing these technologies, demonstrating them, and getting them ready for all of you to use in how we explore space. Thank you.
Thank you. Tim?
Everybody hear me? Okay. Anyways, I'm with Dynetics. I am their propulsion guy, but there's a bunch of us that run around and do that. I also work as commercial space advisor. We are a mid-tier company. We've got about 1,300 employees, and we are trying to really build a space division. And part of that was major investment from the company. We invested many $1 million in FastSat and flew a NanoCell D. We built that, and they bought my company, Orion Propulsion, and that was part of a building strategy to start building a lot more hardware. Got a brand new building. We're building a 240,000 square feet, I think it is, manufacturing facility. So we're very commercial minded. We just recently went out and put together an XPRIZE team, Rocket City Space Pioneers, and I'm the team leader for that. Anyway, so what we're trying to do is build a fairly diversified portfolio for doing space. We want to go to, have space access, and a lot of people are hardcore, like myself, who want to make that happen. So we're trying to do things a new way and lower the cost of doing hardware. So that's about it.
Great. Thanks, Will.
Hi, everyone. I'm Will Pomerantz. Good morning. Hope you're all doing well. I am from a company called Virgin Galactic. We are a space line. We're also based out of Mojave, California, just a few hangars away from both XCOR and Maston. For those of you who aren't familiar with our background, we really were born out of the Ansari X Prize winning effort and the 3 space flights of Spaceship One. I know, looking around the room, a number of you were in Mojave for those flights or worked for X Prize Foundation or worked on that vehicle, so I won't bore you too much of the details with that. But our founder, Sir Richard Branson, founder of the Virgin Group, saw and was inspired by the first flights of Spaceship One, got involved as a sponsor for the X Prize winning flights in September and October of 2004. And that really was the moment that crystallized a desire that he had long held to create a company that could carry all of us into space, that could really democratize access to space. He realized, as the Deputy Administrator said, I think so eloquently this morning, that's not really NASA's job to create a spacefaring civilization, a space settlement. They have a unique role to play in that, but someone else needed to come in to do that. And so said we would do our part by setting up this company called Virgin Galactic. We have built and are currently testing essentially a scaled up version of those vehicles that flew in 2004, whereas Spaceship One could only carry a maximum of 3. Spaceship Two will be able to carry 8. That is 2 crew and 6 paying passengers. So we've built a correspondingly larger vehicle as well as a larger mothership. And again, those have been built now. I think White Knight 2, our mothership, if I'm remembering correctly, has flown about 68 times now. The spaceship has flown somewhere on the order of 15 times now. We are taking deposits now. I think we've taken about $55 million in deposits. That works out to 440 or so passengers who are lined up to fly. Our core business really is the tourists. It is the people who are going for fun. But we recognize that the scientific market and sort of the engineering R&D market is an increasingly important one, both from a dollars and cents perspective and also from sort of a company ethics perspective. We think that these vehicles, whether they're ours or the other folks down the roads, have a really important role to play in shedding some light on our home planet, as well as developing new technologies that are going to benefit a wide variety of businesses. And obviously, we're looking forward to doing our part with that, whether that is carrying untended scientific experiments or someday carrying both scientific experiments and the experimenter.
Great, thank you very much. One of the reasons that I came to Ames is because of what Dr. Warden is doing and how he's been looking at how public-private partnerships can really help make a sustainable industry, what should government be doing? And you've heard what Laurie said earlier, there's a lot of debate about the role of government in starting new markets, from we should stay away to that we should be anchor tenants or anywhere in between. And so the first question that I have, I'd like to hear from each different perspective is, what do you feel the role of government is in the particular markets that you are looking at? And Sean will start.
First up to the firing line. The role of government from Maston's standpoint, and perhaps more broadly, is to be referee, to kind of set the ground rules and to make sure people are playing by them. But space is a little bit more complex than that, and we really do believe that the government does have a role as a customer and as a catalyst to help move the technology that has been in the government purview for many years into the private market. Now, I'm a startup guy. I've been around and worked through many startups, and you would think space and bureaucracy and FAA are completely opposite end of the spectrum. What I can tell you is that my observation is there's a lot of folks that are part of the government that see the opportunity here and are working diligently to help make sure that we're making that smooth transition. It's still on us to perform. If we don't perform, we don't get paid. Your tax dollars are being well spent in that the government is supporting us when we perform.
Great, thanks. Kaki.
Well, I think it's best solved by trying multiple approaches, and so I made a list here. first thing I think what government can do is increase the current launch volume and reduce the payload mass. The current launch volume is too small to sustain a healthy economy for expendable launch vehicles and make a viable industry for reusable launch vehicles. I'd like to give kudos to NASA with Cruiser right now and helping make that, start that initiative. The other thing I think that we can do, or the government can do, is make government investments of about 50 to 100 million in private equity funds. Now the president exists for this. CIA has a VC fund. NASA had a VC fund called Red Planet. And if something like that starts up again, the thing though is it needs to agree with industry. It needs to agree with Commercial Spaceflight Federation mandates and get with us and not be another essentially government program. The other thing the government can do is increase the national research and development grants for science experiments on our vehicles. Again, Cruiser's doing this. But whether it's payload missions for life sciences or Earth observation or planetary investigation, or technical analysis and measurements for stuff like aero and propulsion performances, or advancing instrument, TRL, the money has to come from across the board, from NSF and NIH and NOAA, as well as NASA and the DoD agencies. The things that government should not do is don't put IP claims on SBIRs and SAAs on the small business initiative research stuff. The IP comes from us. We've started it, and it's not government's. The other thing is, along those same lines, don't levy regulation upon regulations. Paperwork is going to kill us. We're small companies. We're commercial companies. We want to get to market quickly, so we have a formula for doing that, and it doesn't involve a load of paperwork. And then the other thing is that nasty four-letter word called ITAR, and just do not apply it to what we do.
Great, thanks. A lot of agreement there.
For the Flight Opportunities Program and for Cruiser, we are trying to be a good customer. For there's two sides to that. Buying the products we need and buying them in a way that safeguards the taxpayers' money. I think what we've done, what Sean was referring to, we started off this way. We're buying rides, we're paying after the ride is completed and the payload is safely returned. We're also trying to invest in the new technologies that will help these companies succeed. And that's part of what OCT is really investing in. Some of these things like the propellant storage, making parts in space. There's one that was very interesting at looking at doing fire suppression in zero gravity. So there's that aspect of feeding technologies to you all, getting them out there, doing the technology transfer, and there's being a good customer. There's another one that Sean kind of hinted at, and Kaki did too. We're exploring how to do things in a different way. One of my early bosses estimated that it took about 25,000 pounds of paper to get a payload into low Earth orbit. We're trying to minimize that. But it's sort of changing the direction of the Titanic, but we're working on it. I think for the country, NASA's role is to explore. We need to turn over a lot of the things that we have explored and let that become a new national industry to build our economy. That's what we have to let all of the private industry do, and we're learning how to do that as we progress in this. I think the other roles are make sure we figure out how to do this safely, but accept greater risk. That's a new challenge. We've, for years, looked at preserving the lives of our coworkers that are astronauts and pilots, and we want to make sure that we don't endanger anyone as we progress with this. But going to space is risky, so we know that. We're trying to figure out how to work with that.
Great.
Okay, as far as the government's role in what we're doing, you know, I think probably first of all, we need to, I think, certainly for suborbital things, I think it would really be cool to continue to push the teachers in space and things like that, with certainly experiments, teachers going out and flying experiments in a suborbital fashion. I can't think of anything more inspiring and personal to the students to be able to be part of that. I think we got to figure out I think it's really, but in order to have a good education program, you've got to be able to make it relevant to the taxpayers. They got to believe that it's a good idea. And right now, it's unclear if the taxpayers who pay the 30-something cents a day or whatever it ends up being of those taxpayers, it's not clear what the value they're getting. You know, in the past, the value's been, well, we've got the shuttle going, we got the space station. Those are cool, and they're very inspirational. And we know that a big percent of folks support NASA. A lot of them don't know why. We better give them a reason why, because we won't be able to continue to ask the good taxpayers to support us. So we've got to make whatever we do very relevant, and if we're not flying, I don't think we're going to be relevant. So we've got to fly something, and it's got to, and Americans have to feel like they're a part of it. And so education's good for that. So I think that's a good place for government. Whether you extend that on into orbital and beyond, I don't know how the funds are going to hold out to do that. But I think supporting sciences and continue to sell education and making it really a big movement. And we got to learn how to do better marketing. And by the way, I think the government needs to really understand the needs of the industry too. They really got to get out here and survey the industry and say, what do you need now? What will you need in 5 years? What are your challenges? How do I not get in your critical path but also add value? I think the government needs to put things in context of, you know, this is unmanned, this is manned. We can do a lot of things in the name of development, and we shouldn't have a lot of paperwork imposed on us at this juncture. We can do that, and typically people who are creative and develop are different people than, say, process production people. And I think there's a time to bring all that in. But, and I know this is very relevant right now with the idea of, you know, of SpaceX versus FAR. You know, when do we bring in the regulations? So that's my 2 cents.
Great. Thanks.
Well, I think I agree with everything that's been said, but to try and add a couple original things to the piece, two main points come to mind. One is my academic background is in the sciences, and having worked in sciences for a while, I recognize that, you know, PIs at universities around this country and at research institutions around this country are extraordinarily creative about finding new ways to do new and original science with every capability that they're given. But the funding structure that's set up to fund scientific research labs does not really give them the means or the incentive to think about the capabilities that might be coming a few years from now. So I think programs like Flight Opportunities Program play this really important role of priming that pump and taking a capability that's sort of just over the horizon and giving scientists both the reason to and the means to think about how do I exploit that now. If we didn't have a program like Flight Opportunities Program, I think what would happen is a few years from now, when all of our vehicles are in regular commercial service, then the scientific community would realize, oh man, this is a really cool new lab space for me to play in. Now I need to think about recruiting graduate students and building apparati and getting grants and all those kind of things. And so there would be this multi-year lag. And I think Flight Opportunities Program for, what, 1% of 1% of NASA's budget, which in turn means 1% of 1% of 1% of the federal budget, is going to cause in the very near future, you know, multiple years earlier than it would have happened otherwise, hundreds of flights into space, hundreds of really unique flights on high altitude aircraft and on VTVLs that just would have happened further down the road otherwise. The other thing, and perhaps I'm misinterpreting the question, but I think for the most part we've taken the assumption you meant federal government.
Yes.
I think I want to note state and local governments also have a really important part to play in this. We at Virgin Galactic, and I dare say the other companies as well, have really benefited from the thought leadership in places like Kern County, California, and for us in particular in the state of New Mexico. These are places that have shown the vision to, in some cases, invest money, in some cases substantial amounts of money, but also to create the regulatory regimes, the liability projection that are going to allow our kind of companies to enter into business without being subject to predatory lawsuits and things like that. That is a role that I think, broadly speaking, the advocacy community doesn't properly recognize, but it's really critical. If we didn't have those state legislatures in places like New Mexico and Florida and Virginia and Texas kind of sticking their necks out for an industry that probably a lot of their constituents don't necessarily understand very well yet, I don't think any of these companies would be where they are today.
That's an excellent point. So the hard questions are starting to come in now. Actually, Will, what you talked about, you foresaw hundreds of flights in the future. So we have a question here that says, ultimately, suborbital spaceflight is likely to reach market saturation point, where the industry will become somewhat more stable as an operating industry rather than the currently R&D heavy field that it is. What do you see the market point for this being? In other words, how big do you expect the industry to grow before stabilizing? And I'll let anyone who would like to answer that question.
I think that would be a great question for Dougal to start us out with. Push him right in front of the bus.
I can say for the Flight Opportunities Program, we are trying to design the program for getting roughly a flight a week. That means that it is changing quite a few paradigms. How do we prepare payloads for that type of flight rate? How do we sustain that? How do we get the interest? How do we get the industry and the research community building new technologies that we want to fly on this? It opens up a whole bunch of other opportunities too, where people can try something where they don't know it's going to work, but they know they'll get another chance to fly it in about a week. That has really changed a lot of thinking at the NASA centers. And I believe it's now going to reach out to the rest of the community. We also have in our charter to go out to find the other laboratories around the country and hopefully around the world that will support and use this industry, because we have that charter, I think Lori mentioned it, and we've really started talking about settlement, getting outside, living on other planets. If we're going to do that, we need to come up with a whole new set of technology that can get us there, sustain us there, and keep us surviving there and working back and forth. To me, that's the huge challenge that we have, and as somebody that loves to create things, I think this is the most wonderful time to be in this industry.
Great.
Since I pushed him in front of the bus, I'll go ahead and jump in front of this as well.
Great.
The answer to that question is, who the heck buys books online? I mean, I'm 15 years too late with a question, but who the heck, you go to a store where you can pick it up and flip through it, and we know that paradigm has shifted. That's what's happening. But I'd love to know who asked the question, because I can bet it's someone who's trying to write the report and wants the right answer. We spent a bunch of time trying to answer this question, and the answer is way bigger than today, and we're going to bring that capability online, articulate the benefits, and try to respond to the market as it develops. So,
Anyone else?
Yeah, I'd like to address that. To have a viable suborbital market, we need to have about 200 to 300 flights a year. And that is, we're still a long ways off with that. And I think we all have sort of have addressed the ways to go about that. But there's also another way that suborbital vehicles are going to evolve, and that's sales of the vehicles themselves. So for space tourism, for research, education. Right now, XCOR is already seeing that with a wet lease to Space Experience Curacao, where they're going to fly the links off that Caribbean island, primarily for space tourism. In fact, primarily. I can see research institutions. Right now, XCOR and Virgin have a agreement with Southwest Research Institute to fly their PIs and experimenters on our vehicle. And I could see Alan Stern coming to us and saying, we can't get Dan Durda out of Mojave and out of the links. We want our own vehicle, because when we want to fly, XCOR's flying it. I can see space studies programs, a lot like oceanographic institutions who have their own research vessel. I can see them purchasing a suborbital vehicle. So not only are you looking at flights, you're looking at purchase of the vehicle themselves.
Great. Anyone else? Tim?
You know, I think the government is going to have to put a serious educational outreach program together that is aimed at doing suborbital experiments and things like that, and we don't have that today. When you think about why NASA exists, one of the big reasons is certainly exploration, doing the hard things, but it's for education. It's to inspire. That's why the taxpayers don't mind paying for it. It's because it's an inspirational tool that we control. We pay for it because we know that NASA's never going to pay for itself. So what are the returns on our investment? Well, there's inspiration. There's doing things that private industry would probably never do because it's too risky. That needs to be done. That needs to be a focus. But I think it's also, you've got to keep the kids interested in this country to pursue math and sciences. And you don't do that if there's not a program to do it. And to me, the most bang for the buck would be through suborbital activity, because a little bit of money could go a long ways, and that doesn't have near the risk. I mean, your order of magnitude difference in terms of your velocities and your reentry and all that. So it's a lot easier. So to me, it makes sense that the government invests some money there, and we see a lot of exciting activity surrounding programs that are aimed at that market. Because the government is going to be a big customer, but they need to sell it properly, and they need to excite people. And if they don't do that, we're really going to be limiting ourselves of how much flying we can do. And the better we get at it, the more you're going to want to go do something harder, and you're going to be pushing the envelope, and your industry will eventually get there. But we don't have that today. We need investment, but it's a marketing, selling thing we've got to do, or the agency. That's my 2 cents.
Tim, do you want to venture numbers of per year or orders of magnitude? Or?
I think it's. I haven't studied it, but it's clear to me that it could be huge if the government wants to do it. Okay. Because we're not flying space shuttles anymore. We've got a space station that we can get to with the help of the Russians. But fact is, what are we doing in the meantime? And these sort of programs could really be spooled up if there was some money thrown in there, and someone could market it and show the public what a great value it is, show teachers flying in these various vehicles. And no, I don't have one, so I don't have an agenda here, by the way. I purely just think it makes good sense. So I can't estimate.
I appreciate it.
Being here in Silicon Valley, it's a shame that I'm going to misquote this, but you'll get the general gist. I think it was von Hoffman or someone in the early days of IBM who said, I can never foresee a need for more than 10 computers in the world. Yeah, you recognize this quote. I apologize for messing it up. But I think right now a lot of people in the space industry, broadly speaking, the people in the space industry who wouldn't be interested in coming to NewSpace 2011 are thinking the exact same thing. And with a little bit of wiggle room, depending on your definitions, as of today, something like 523 people have flown into space in something like 50 years. That's not a terribly good rate. And that's a number that to me is sort of simultaneously awesome in the literal sense of the word, that we have a species that's capable of putting 523 people into space, and horribly depressing, because God, should that number be bigger. I think with companies like the ones that are represented here and the Orbital folks that are going to be speaking on the next panel, we are going to leave that number in our rearview window really quickly, by a long shot, very soon.
Great. Another question from the audience is that I think it's on the minds of many people here, and they state that, but people want to know, when are the first flights? And if you're not willing to say when the first flight will be, would you tell us how much notice will you give us ahead of time that first flight will happen, or when it will happen? And we'll start with you, Will.
Yeah, I can start on that one. It's a good question. Never heard that one. It's the official answer is the right answer. They'll happen when we're ready, when it's safe to go. We recognize, this company, none of these companies want to sustain an early accident, especially when, like us, you're putting your billionaire founder on the first commercial flight. You have every incentive to make sure that there are really no glitches at all. But on the other hand, our vehicles are built. We're in a test phase program. It is going extraordinarily well, knock on wood, that it continues to do so. We have really tested out almost all of the aerodynamics of the vehicles. We, in parallel, are testing the rocket motor on the ground. I think if you're trying to chart out a flight date for Virgin Galactic, first commercial flight, you could have drawn up a certain set of milestones. Finished construction of carrier aircraft, check. Finished construction of spacecraft, check. First flight where you carry the spaceship below the mothership, check. First flight where you release it and glides home, check. The one we've just crossed is the first feathering of our wings, and quickly, for anyone who's not familiar with that, one of the particular innovations of our spacecraft system is that as we re-enter the atmosphere, we're in a winged vehicle, but we're essentially a transformer. We can fold up those wings when it's not convenient to have those wings. So for the initial part of our reentry phase, we behave more like a capsule. And then when we've dissipated some of that energy, we can fold our wings back down and glide home. We have now tested that successfully. The next really major milestone will be when we integrate the rocket motor into the vehicle and take the tests that we've been conducting separately and start conducting them together. And can't give a date on when that's going to happen, but it's not all that far away. And then you'll sort of notice our first flight by intention will be a very short burn. We're going to put it in, we're going to tap that engine, make sure all the plumbing's hooked up right, turn it off and come home. And then you'll be able to see a pretty fast progression of just a few seconds to several more seconds to several more seconds until we're getting up to our full duration burn, which is just over a minute.
Great, thanks. Anyone else?
What he said, with the exception of the billionaire founder. We're getting there soon. And in answer to, will you have advance notice? Yes. No, you'll have advance notice. I didn't say how much. No, sorry. The real answer is we are quickly moving through the steps that we need to. It will be happening soon, and our plan will be to give all of you fine people an opportunity to know that we are flying for our major milestones before they happen.
Great. Anyone else? Thanks.
Yeah. Can't avoid this one, huh? We will be in flight test operations by next fall. That's all I'll say.
Great. Thank you very much.
I can get you probably up to 30 feet on a rocket belt I built. We won't require any FAA authorization, and
Let
if
us
you're
know in
ever
advance.
for Alabama, I'll let you fly the water rocket belt.
Great.
But that's about it.
I'm going to visit you and hold you to that.
Yeah, great. Did you want to say something, Dougal? That's great.
I'd like to say that it's, from my side, it's been nerve-wracking because I'm really excited. I thought we'd be already going in December. I think the other big thing is a lot of us from NASA have learned schedules and trying to hold them, we do at our detriment. We're waiting, and we're waiting patiently. We want you to do it right. We're not going to push you at all. I think the public might, but we're going to hold off. We came this close to flying, and they had some problems. I think I want to give some kudos to Armadillo. They had 2 incidents where their vehicles failed, and they shared very publicly the lessons learned, and I was very, very proud of them for doing that. It was also some spectacular footage of watching these things. So if you haven't had a chance, check out their website. But we encourage that. They're trying new things and experimenting. Keep it up, keep going. Let us know when you're ready.
Great.
Hey, Dougal, if the government put in more money to what we're doing, you wouldn't have to be so patient.
There you go. All right. There. All right. Hey, so Tim brought up the FAA a little bit. In fact, we just got a really good question about the FAA. I know Ken is here somewhere. Maybe he asked it. What has your experience been with the FAA? Are there expectations for your commercial flights clear? Do you have any concerns about vehicle certification and fair use of aerospace? Which are great questions. Would you like to start?
Sure, I can start. Yeah,
okay.
Did I see Dr. Neal in the audience? So we have some fine representation here from FAA-ASD. I can say, and I would say this if he weren't in the room, you know, as a general rule, George's staff and George as an individual have been an absolute dream to work with. I think they've been given a really tough job of being government regulators who are asked to have this encourage, facilitate, and promote aspect, and to be really forward-looking in a way that I think generally government regulators aren't asked to be. That's, I think, often more of a retrospective kind of job, and they've been asked to be really prospective in coming up with regulations that make sense for vehicles that haven't been built, and really that vehicles of their ilk have never been built or flown, certainly not at any large scale before. So there are growing pains, certainly. Obviously, there are new equations that need to be worked out. There are new systems that need to be worked out. There are ways of communicating frequently that need to be worked out so that they're not overly a burden on us or on that office. But I think as a general rule, it's been way, way easier than I could ever have imagined.
Excellent. Anyone else like to comment? Or?
It consumes a decent portion of our resources, but it seems to be fully appropriate. We're going through the process, and the coordination that we see between several different government customers and government agencies has actually exceeded my expectation. I thought there'd be a lot more trying to get this group to coordinate with that group. You know, it is a barrier. For anyone that wants to start a company, it's a huge barrier. Don't start another company. We have enough competition already. But honestly, it is the sort of thing where going through the process is, while sometimes painful, is certainly beneficial. And the commitment of the individuals to help figure out, okay, we hit this roadblock we didn't know was there. The people that have been trying to help facilitate this have been excellent. So
That's great.
Can I give an additional answer wearing a different hat, taking off my Virgin Galactic hat and going back to my previous job. I spent several years running the Northrop Grumman Lunar Lander X Challenge at the X Prize Foundation, which Maston is one of the winners of, as well as Armadillo. And I think generally as a class, when we talked to those teams at the beginning of that competition, most of them said, I think that building a rocket is going to be about 20% of the job and dealing with paperwork is going to be about 80% of the job. And found at the end that that was almost reversed. Now, most of them, probably like a lot of people, at least historically this would be true at this conference, are pretty libertarian and think 20% is still way too much. And I think we can always drive that number lower, but it was a lot better than most expected, I think.
Excellent. Any other comments? Okay. Kaki, did you? Okay. Well, I'll go on to the next question. People are wondering, will you be hiring any commercial astronauts anytime soon?
no.
Okay.
Define soon.
Well, let's just say in the future. Actually, I added the
We
soon,
will,
so
we
I
will
mean,
need
someday,
pilots.
would you
We
like?
will need pilots,
You will need pilots.
yes. So if those astronauts are pilots,
Great.
then yeah.
Yeah, we just had a job opening for pilots that we've got some really fantastic candidates lined up that I can't tell you about just yet, but they will impress you all. So yes, we will be hiring pilot astronauts we'll be announcing the hiring of pilot astronauts in the very near future.
Near future, great. All right. We just got an interesting question, and I think it was alluded to a little bit earlier about what the markets are. So we didn't talk specifically about, this question actually says, what are the potential of Chinese and other Asian markets for suborbital flight? But I think you could expand that to international opportunities. Would anyone like to comment on that?
We're working with the Italian Space Agency and a couple of private companies now to fly a payload that will sample particulates as it flies through the upper reaches of the atmosphere. I believe there's a whole lot more that are very interested in this. We have been tentatively approached by Brazil and a Spanish company. There are some others that have expressed interest. ESA was very interested in this market and testing things out. Much of this for the suborbital is a lot of interest in looking at what's going on in the atmosphere, how things are changing, what can we do about it. There's also a great deal, I think, of interest in developing the tools for the infrastructure. So the Europeans, South America, we have not heard much from the Asian companies yet, but there is interest there, and looking for this market to get going.
Great.
We've had a lot of interest, international interest, in our vehicle and in flying experiments on the vehicle. And that's two things there. One is actual use of the vehicle itself. We have a wet lease with Yishan, South Korea. At least that's in place. MOU is. And we have other interest in international, including Asian companies, organizations flying payloads on our vehicle.
Great.
Is this the opportunity to drag up that four-letter acronym again? Was that
You
queued
could.
up specifically to be a ITAR as the 800-pound gorilla that weighs upon our shoulders?
I think it's a good opportunity
Okay.
to bring up that.
ITAR is an 800-pound gorilla that weighs on our shoulder. Now,
Yeah.
it's we too have fielded a decent amount of inquiry outside of the U.S. And one of the beautiful benefits of democratization of space access or reducing the price point is it's drawing in not just people here in the U.S., but literally around the world. The constraints of ITAR, the confusion that surrounds ITAR is one, internally sometimes we're not sure, is this just a boogeyman or is this really serious? If we get it wrong, and it really is something that we run on the wrong side of, it can really, really hurt us. So those of you who are helping advocate for carve out for ITAR around NewSpace, thank you very much. For those of you that aren't, welcome aboard. So it is definitely a negative drag on the industry at the moment.
It's a good point. Excellent.
Thanks. When I ran a company, it's the ITAR thing is a scary thing, by the way, because you don't know who within those organizations will misinterpret what you're doing. Yeah. And various people can have agendas to move up the ladders, and you don't know. You might become a target for something, and it's very, very benign. So as a rule, you just say, I got to avoid anything having to do with any foreigners. I mean, you either take that stance or you decide, I'm going to have to hire some really good lawyers, and we're going to spend a lot of our time looking at something. We may never get any business from this. It's a very difficult thing to get your arms around, and it changes depending on what's going on in the world of how much emphasis they put on foreign trade, and certainly, technology. Some of the stuff we're doing is not leading edge. It's just being done on a whole lot cheaper. We're trying to lower cost. We're not trying to push the leading edge in some cases, but it is very difficult to understand what ITAR can mean. What we do know it means is, fact is, we're not going to launch any of our important satellites on foreign launch vehicles. We know that, and that's pretty much sort of a protectionism program for the big guys. So they'll always have something to launch, which is interesting, but for good reasons. We have national security we got to preserve. But you know, you do get some. We signed up a deal early on with a South Korean company, and then there were folks within agencies didn't like the idea that we were possibly going to be doing engine work with any foreign company. So we pulled out of the deal. And later I would get contacted by other countries, and we would, some of them I would ignore. So one guy wanted to buy, over in Orient, wanted to buy a rocket bicycle, but he also wanted a really cool low-cost rocket for looking at monsoons and things. So you get all kind of calls, by the way, from different folks, but as a rule, I just ran the other way because we were scared. But we might have missed some very legitimate opportunities to grow the business, grow the markets. So it would be cool if there was a corridor within a NASA agency where they speak rockets too, because we're on the same page technically, and you help carry a technology through a corridor that leads to ITAR and beyond, because it scares us to death. And I believe it's in some ways it's preventing us from growing some customer base and maybe some investment in where there's really nothing bad there. But I don't know if that's possible, but it'd be cool if NASA, because someone needs to be smart enough to discern what you're pitching. But it's very difficult.
And in time, that will force innovation outside our borders. Our competition, we're in it's still kind of a kumbaya where the market's growing, we get along very well, but eventually the continuation of an ITAR regime makes starting that company here more difficult than starting that rocket company somewhere else, and will drive those companies elsewhere. And we
As
don't
we've
want
already
that.
seen, yeah.
Yeah.
Yeah, I think purely from a business perspective, there is no reason why international markets should not be an enormous part of this, just from a financial perspective. There are customers, whether they're tourists or scientists or professional astronauts or whatever, from all around the world that want to fly on these vehicles. And also, just as a fact, with all due respect to our colleagues on other side, outside of this country, the United States of America has an enormous lead in this industry right now, both from a technological perspective and from a regulatory perspective and from an availability of capital perspective. We're way ahead of everyone else. So the only reason why we shouldn't swoop in and capture that entire market and bring an awful lot of dollars and an awful lot of innovation right here to the United States is if we're legally prevented from doing so. It's clear, I think, that when the ITAR, which as Tim mentions, is a well-intentioned rule, we need some policies like that in place. But when those policies were written, they did not presuppose an industry like this and vehicles like this. The rules weren't written for that. And that has resulted in some, shall we say, market inefficiencies that I believe there are some movements underfoot now to hopefully iron out.
Great, thanks. So there's a couple general questions that all kind of fall together. So what people are asking are, can you talk about what your current capabilities are? But not only that, can you talk about where you see your capabilities evolving in the future? We're at the beginning, but what do you see out there in the years ahead as new capabilities or places you want to strive for, if you're willing to talk in that area?
Certainly. I can talk a little bit about where, we say current today, being able to take off vertically and land vertically. I know it's been done in movies since movies started, but turns out it's a little bit difficult. So we currently have, and this is one of the things we've talked a lot about flight here. But one of the things that Maston has seen a lot of interest in is our ability to do descent and landing. So that's a technology we have today that has benefit more than just, hey, it's neat. There are a lot of people that are looking at developing technologies along those lines, and are working with us to try to test out those technologies. So that's something we can do. We are doing today. We have paying customers on those things today. Paying customers, by the way, holy grail, love them. In terms of the flight capabilities, right now, the highest a Maston vehicle has flown to date is 1,000 feet off the deck. We will be quickly expanding that envelope. In terms of what capabilities you're going to get on that flight, show up with a proposal and we'll figure it out. If you're looking at observation, you need to sample the environment. You want to be inside a payload bay. We're flexible. We iterate very quickly. So if you know, here's the flight plan and I want to do this sort of thing, we'll figure out how to make it work. We have the in-house ability to modify the vehicle to match whatever that might be.
Great. Thanks. Khaki?
Turn this thing on. Yeah, as I said, the Lynx is a horizontal takeoff, horizontal landing vehicle. It has 2 seats, a pilot plus 1. It's a small vehicle, and it will have multi-mission capabilities, in-cockpit experiments, external mount experiments, test pilot astronaut training, upper atmospheric sampling, small satellite launch, and space tourism. That plus 1 can be either a spaceflight participant or it can be a 120 kilogram payload that can be something like a 19-inch rack with a couple mid-deck lockers in there. It will have aircraft-like operations, and we will do it with high-tempo operations. We expect to fly up to 4 flights a day, and we'll have rapid call-up, we'll have fast turnaround, and low-cost operations and maintenance. Right now, we're building a Mark I prototype. We will evolve to a Mark II production model. Differences there is primarily in performance. The Mark I will go to 61 kilometers in altitude and provide about a minute of low gravity. And then the Mark II will get to about 100 kilometers in altitude and about 3 minutes of low gravity.
Can you comment on how many vehicles that you're looking at in these phases? Or?
Well, the Mark I is one vehicle, and then as needed, Mark II being the production model, as needed, we will produce more.
Great, thanks.
Well, we are working on some small orbital rockets that have a pretty good suborbital capability, but we've just had long burns and some boosters that we've developed. But as a company, we definitely we're working on some other systems that will should be interesting for unmanned stuff and small stuff. So just stay tuned. I can't tell you any more than that, but we are working some cool stuff.
How many kilograms to the moon?
Well, we're having to fly on a Falcon 9 to do that, by the way. So for all you guys who are interested in secondary payloads, we'll fly you on a Falcon 9. We can take actually quite a bit. We're taking a few 100 kilogram payloads over there if the market pans out. So we'll see.
Great.
And then from our end, with Spaceship Two, we can carry 6 paying passengers plus crew up to 110 or so kilometers. And we can do that routinely. I mean, the hope is that we'll be doing that daily, in fact, hopefully multiple times per day eventually with a vehicle fleet that spans multiple vehicles. White Knight 2 actually is also a pretty interesting vehicle. We may not think of it as much as resident space geeks, but for a number of people, having an aircraft that can carry a few tens of thousands of pounds up to altitude and maybe let it go is really interesting from a scientific perspective and from others as well. We are a company that sort of sprung from the minds of people like Sir Richard Branson and Burt Rutan, and so certainly there are visions to go further. I don't think there is a horizon to Sir Richard's vision. I think it sort of extends limitlessly off in the distance, and he loves to give us all a friendly prod by saying in the public what we're going to do next and when it's going to happen, which is great. I mean, he wants to do orbital flight. He wants to do hotels or work with other people who are doing hotels, and God bless them, those are all super fun things that we're all thrilled to work on, but right now we're focused on the core business.
Great. So I've got a few questions up here that talk about training and payload preparation and what a person has to do to go through. There's questions on the price point, like if you could give some ideas of what the cost. Would you like to have a couple comments about the user? How hard is the process to come and use these capabilities, and maybe orders of magnitude on the cost, however you'd like to talk about it?
Cost is a difficult question because, unfortunately, you don't all agree on exactly what it is you want. The customers, everyone says, oh, well, everyone needs all to be standardized and it'll be great. But everyone expects that standard to be their standard, not their neighbor's standard. So what we found is what we're trying to provide some core services. So any payload, let me address the payload, any payload will have to go through a minimum, and we've tried to reduce this as much as possible, shake and vibe test and an EMI fit check, just to make sure your payload doesn't interfere with our vehicle and thus threaten your payload. Depending upon what you want to do, and we're working with several other payload integrators, we'll have the ability to step you through to figure out what's necessary. Some people want to specifically have access to the atmosphere, others want to be sealed. I mean, it is across the board. I have not yet seen 2 requests come through that are even 50% the same. It's a lot of diversity. It's phenomenal. The price point is just going to depend. I know we're looking in the future of having very reduced price for these sort of services. Right now, the answer is we're trying to be both cheaper and faster than your existing options for suborbital research. That's a goal, and I'm going to do everything we can to make sure we hit both less expensive and being able to turn that project much faster.
Excellent. Thank you.
Since we're on the subject, the retail price of the links is going to be $95,000. It will be less if we sell in bulk. And like Sean saying, anything above standard is going to cost extra. There will be some rides. We do have some payload, secondary payload places that obviously will be less and can be done if there's a primary payload. So that's basically our price. As far as tests go, yes, there will be screening and training for the spaceflight participant. There will also be essentially screening and training for the experiments too, and we're working that out right now.
Great. Thanks.
Well, we've been designing a vehicle. We were targeting $1 million a launch, but the range will cost you at least $2 million. And that's just the way it is. But that's been our target point. This is unmanned. This will be 25 pounds to LEO, and we'll see where it goes. And that payload capacity is being pushed by our government customer right now. You can throw a lot to suborbital if you can throw 25 pounds to LEO from quads. But anyways, we'll just see where it comes out. But until you fly something, we don't know where our cost point is. We've been trying to target $1 million for a throwaway small launcher. We'll see.
Great.
For costs, you can do some quick back-of-the-envelope calculations. On a tourist flight, we carry 6 passengers. They're paying $200,000 a ticket, so our revenue is $1.2 million a flight. My colleagues and I like science, but not so much that we want to give it away at the exclusion of a flight that we could do that would earn us revenue. So you can work out, we're going to carry for about that much money, about that much payload, six people on their seat equivalent. And as Sean and Kaki said, it's difficult to give an exact price point because everyone wants something different. And what you're carrying and how heavy it is and what services you expect it to be provided with are all going to drive different prices for everyone. In terms of the preparation, clearly it'll be different if you want to carry a person on board or just an experiment on board. Probably one of most interest to you all is carrying people on board, and I will say there's at least one person in the audience who has done the centrifuge training on our flight profile, and you can talk to Keith, and maybe there are others here as well who have already done it, and they all seem to say that it was pretty easy, and in fact even pleasurable. The zero-G side, I think Zero Gravity Corporation has done a great job of showing, heck, Stephen Hawking can fly, just about anyone can fly in that kind of environment. So it will be something where there is some preparation. Certainly there's training involved, both from a regulatory point of view and just from a sort of practical safety point of view. But it's something that we're confident that almost everyone who wants to go will be able to go.
Great. Dougal, did you want to?
I want to kind of, it's a little bit hard to answer this from the Flight Opportunities Program, but I do think we need to do kind of an advertisement for it. We're giving the rides away at no cost in dollars. There is a cost in some paperwork. There is a cost in preparation, reviews, showing us that your payload is safe. But other than that, if you have a payload ready to go, propose it, and we will consider flying it.
Excellent. So we have just a few minutes left, almost at the end of our time. I'd like to give everyone an opportunity maybe to make a final statement, points that you might not have gotten across. If we can do that pretty quickly, we'll stay on time. Sean, or is there?
As I've mentioned, I came from a startup world, and I really am very, very enthusiastic about the interest in space. I love the fact that the people here, you see maybe a story in the news, and you get the fact that there's a lot more than just the headlines. And so from the Maston perspective, it is phenomenal to see the sort of interest and the customers. And personally, and as a company, we see a huge industry of which Suborbital will be a small part of, and I'm very excited. We're very excited that there's so many folks that are interested in joining us on that trip. So,
Great. Okay.
There's been a lot of talk and questioning about what's the space equivalent to the 1920s Airmail Act. And from sitting here right now, I think what I see is things like cruiser as being that, things like commercial crew development as being that. We also feel that things like propellant depots are that where a suborbital, any kind of suborbital vehicle can take that cargo to a propellant depot, and all those things can come from government, and are coming from government. So let's go.
Thanks.
I'd like to kind of pick something that Tim said and put it out there for the whole community. On the education side of things, there's a very big company here in this area that really started out by feeding education. It's called Apple. I think you can all see where they have gone. They put out products that we didn't know what would turn out, and whole new industries have started up. I think approaching that, getting it into the hands of the kids, and letting them dream and grow with that is going to be a huge impact to this whole area of exploration of space.
Great.
Yeah, I agree, and you know, if you don't, NASA has got to certainly establish a few directions that America understands. They've got to go sell, and you know, we don't have a Von Braun today up there selling something every day to Congress or whoever, but if they don't sell the public on the value of the agency, we risk losing that mechanism to do cool stuff and excite people. And that is the vehicle right now. NASA is a great technical agency, but they're also a contract vehicle, they're a conduit, there are a lot of things to many people. But if there are not programs that specifically not only, you know, address suborbital payloads, but they've got to market the value of that. They've got to tell the public this is going on, and they need to do it in a way that's fun, you know, whether it's a Disney format or whatever it is, they need to sell it. And they need to do that in every area of the agency. And otherwise, Americans, it's going to be unclear what the value of the, for the taxpayers is. In my opinion, if we're not flying shuttle, What are we doing? And if you say, well, we're doing cool technology, well, what is that? What does that really mean? How does that apply to me? And how does my family get value in that? And I believe if we don't sell that, we are going to be, the agency is going to be hosed, and we won't get taxpayer support. And I believe at this early stage of this industry, if the government is not our customer, then you guys can't go out and raise investment because you're unsure of what your real market is at this juncture. Now, for William here, he knows that people are interested in suborbital tourism. You know, they're getting deposits, so that's clearly, there's a market there. Don't know how big, but I believe this educational component has got to be huge. And we've got to sell it hard, and I think it'll help bridge the gap when NASA's figuring out where they're going.
Great. Will?
I just say, the public's perspective of what's happening in this industry in the broadest sense, not just suborbital, is informed by the media. You all read the media. It's been a constant litany of just morbidly depressing stories, certainly over the last month. It's like hit piece after hit piece, and it's a lot of shoegazing and just really sort of emo people being super bummed out. And I think for those of us who see this as an exciting time and a time of opportunity, it's sometimes easy to say, you know what, I'm going to bite my tongue, and I don't want to get into that fight again, and I don't want to rub it in, and it's easy to let that slide. And I would encourage you, don't do that. Definitely don't do that if there are young people listening, because we don't want people to get discouraged. We have to find a way to present this as an exciting time, and we have to be realistic about it. We can't ignore the fact that this is a time that will bring a lot of pain to a lot of people and a lot of good people. There are smart, hardworking, patriotic people in Houston and Alabama and Florida who are going to be out of jobs or going to be changing jobs in a way that they didn't want to do. And we need to be sympathetic to that. We can't put on blinders and say it's all for the greater good and totally ignore that, because that will evoke an emotional reaction that will cause people to immediately stop listening to what we're saying. We have to be respectful of that, and we have to sell a positive case for why, in the long run, this story is the best for those people and for the country as a whole.
Thank you. I want to thank the audience for excellent questions. I think this has been a great panel, very candid in their answers. I want to thank the panel very much for their time. Thank you.
All right, thank you, Gary. Thank you, everyone, for that. That was a very good panel. I have two quick announcements for you, two logistical announcements. First of all, if you don't have an internet password for Ames, it will be in your registration badge, and if it is not, we have the registration table set up now to hand those out to anyone who still needs them. So just go out there, and there will be people there to help you. And second of all, I'm sorry for the slide.
Firings of said engines. We've built and flown 2 generations of rocket-powered vehicles, a total of 66 times, and I do like to tell you that we have 50% of all rocket-powered flights in this century. We're building a suborbital vehicle that will have multi-mission capabilities, and it's called the Lynx. It's a piloted 2-person horizontal takeoff, horizontal landing vehicle. It has wings. We're funded by angel investors and sales and contract revenues. We don't have a billionaire who with deep pockets, who is the company founder. Our founders founded the company because they want to go to space, and they want to take others with them. And the way our business philosophy works is we start with incremental steps. We focus on safety and reliability and responsiveness, and therefore we've gone from the first vehicle, which is a single-person small vehicle, to a 2-person vehicle, and next will be both low performance. The next one will be a suborbital vehicle, and we can talk about that later. Thank you.
Great. Dougal?
I'm Dougal McLeese from NASA Ames. I have been the manager for the Cruiser project. The Cruiser project has morphed some, and I'd like to explain that to you quickly so you all understand. The Office of the Chief Technologist has come up with a whole new organization that is going to really start developing new technologies. As part of that, they have the Flight Opportunities Program, and within the Flight Opportunities Program, there are two main methods for demonstrating and testing new technologies. One of them is what has been called cruiser. We're now going to start referring to that more as the suborbital reusable launch vehicles, or suborbital RLVs. There's also the former FAST program.
Team Rocket City Space Pioneers, and I'm the team leader for that. Anyway, so what we're trying to do is build a fairly diversified portfolio for doing space. We want to go to, have space access, and a lot of people are hardcore, like myself, who want to make that happen. So we're trying to do things a new way and lower the cost of doing hardware. So that's about it.
Great. Thanks, Will.
Hi, everyone. I'm Will Pomerantz. Good morning. Hope you're all doing well. I am from a company called Virgin Galactic. We are a space line. We're also based out of Mojave, California, just a few hangars away from both X-Corps and Maston. For those of you who aren't familiar with our background, we really were born out of the Ansari X Prize winning effort and the 3 space flights of Spaceship One. I know, looking around the room, a number of you were in Mojave for those flights, or worked for X Prize Foundation, or worked on that vehicle, so I won't bore you too much of the details with that. But our founder, Sir Richard Branson, founder of the Virgin Group, saw and was inspired by the first flights of Spaceship One, got involved as a sponsor for the X Prize winning flights in September and October of 2004. And that really was the moment that crystallized a desire that he had long held to create a company that could carry all of us into space, that could really democratize access to space. He realized, as the Deputy Administrator said, I think so eloquently this morning, that's not really NASA's job to create a spacefaring civilization, a space settlement. They have a unique role to play in that, but someone else needed to come in to do that. And so said we would do our part by setting up this company called Virgin Galactic. We have built and are currently testing essentially a scaled up version of those vehicles that flew in 2004, whereas Spaceship One could only carry a maximum of 3. Spaceship Two will be able to carry 8. That is 2 crew and 6 paying passengers. So we've built a correspondingly larger vehicle as well as a larger mothership. And again, those have been built now. I think White Knight 2, our mothership, if I'm remembering correctly, has flown about 68 times now. The spaceship has flown somewhere on the order of 15 times now. We are taking deposits now. I think we've taken
Get it wrong? X-Corps. Thank you. Sorry, my eyes aren't so good. The Will Pomerantz, who's the Vice President of Virgin Galactic, and Tim Pickens, who's the Chief Propulsion Engineer for Dynetics. Thanks. All right, so what we'll do is maybe we'll just go from left to right, and if you would just say a little bit about your background and what you represent.
Good morning. My name is Sean Mahoney from Maston Space Systems. For those of you who are not familiar with what Maston does, we are building a fully reusable vertical takeoff and vertical landing rocket out in the high desert of Mojave, California. The focus of the company in the immediate term is being able to provide cheap, fast, responsive suborbital space access so that your projects, your research, your technology development testing can be done in a quick and reliable fashion. Looking slightly beyond, today is what sort of things will we have in the immediate term? We are looking at focus on being able to do nanosat launch and being able to do orbital launches a little bit further down the technology roadmap. We are specifically focused on your payloads, and luckily there's a few counterparts here who can talk about being able to carry you to space. Right now, the only way you would wind up on a Maston rocket is if you wanted to have your mortal remains distributed in space. That's about the only way that we're going to fly humans at this point. So,
Thank you very much. Kiki?
Hi, I'm Kaki McKee. I'm
Kaki.
the program manager at X-Corps Aerospace. My bio's in there, so I'm not going to tell you all about me, but XCOR means space business. We're located at the Mojave Air and Spaceport, which is near Sean. In 11 years, we have designed and built 12 different rocket engines and had over 3,500 tests.
And I always struggle with this acronym, but I think it's the Facilitated Access to Space Technology, Space Environment for Technologies. That was what a lot of us grew up knowing as the Vomit Comet or the Zero-G Corporation airplane that does the parabolic flights and tests technologies, experiments out in microgravity for about 20 seconds at a time. My role now is the payload manager for that program. We just completed the first week of the fast flights, and I have to say it was very exciting to see what people are testing out. We had one payload looking to grab satellites with a remote operated, telerobotic operated robotic arm. We had another group testing fuel transfer for propellant storage in space. Another group printing parts with a 3D printer called Made in Space. This is now the beginning of it. We're looking forward to a great future as we start developing these technologies, demonstrating them, and getting them ready for all of you to use in how we explore space. Thank you.
Thank you. Tim?
Can everybody hear me? Okay. Anyways, I'm with Dynetics. I am their propulsion guy, but there's a bunch of us that run around and do that. I also work as commercial space advisor. We are a mid-tier company. We've got about 1,300 employees, and we are trying to really build a space division. And part of that was major investment from the company. We invested many $1 million in FastSat and flew a NanoCell D. We built that, and they bought my company, Orion Propulsion, and that was part of a building strategy to start building a lot more hardware. Got a brand new building. We're building a 240,000 square feet, I think it is, manufacturing facility. So we're very commercial minded. We just recently went out and put together an XPRIZE team.
Activity, and it's so important that government and commercial companies talk and work together. I've worked at 4 NASA centers in my career. 10 years ago, I was the NASA space architect, and we had a team around the country working hard on how humans can go above low Earth orbit. In fact, before the vision came out by George Bush, we weren't allowed to talk about it. And it's great to sit here and actually talk about words like settlement and about how we're going to open this frontier, and to have NASA people allowed to be part of this and looking at how we can work together to make that happen. So I'm really happy to be here on this first panel, because this is where it's really going to happen soon. We're at the dawn of a new age where we're going to prove these new markets are there, and that we're going to be able to capture everyone's imagination. In fact, very soon, anyone in this room or anyone anywhere will be able to ride into space or to do low gravity experiments for short periods of time into space. And this is a really great way to open the frontier. So the way we're going to do it today for this panel is I'm going to introduce each of them, and then I'm going to ask each of them from where they're sitting to give us 2 or 3 minutes of their background and what they're doing. And then I'll ask one question while everyone's warming up and I understand how to use this. And they'll all answer this one question, and then the rest will be from you. And so we'll get started right now. Our panel is made up of Dougal McLeese, who's the manager of Cruiser that Laurie mentioned, which stands for Commercial Reusable Suborbital Research Program, if you weren't familiar with the acronym. Dougal is right there. Raise your hand so if people know. Sorry. Sean Mahoney, who is the Chief Operating Officer of Maston Aerospace. And Kaki McKee, who's the Program Manager for Air Corps Aerospace. That's it.